Right, year 13 maths. This is 9J lesson 2. And it's talking about writing down differential equations. A differential equation is just an equation which contains a derivative. Now, at this stage, we don't know how to solve differential equations. We won't be able to do that until we get to the end of the integration chapter. So the rest of 9J is just talking about turning words into equations without solving them. So example 31. I'll read it and write as I go. In the decay of radioactive particles, the rate at which particles decay. So rate means something over t. So if I say n is the number of particles, rate of change, the rate of change, rate means with respect to time, so this is the rate of change. The rate of change of n. The rate at which particles decay is proportional to the number of particles that are remaining. So because it's a decay, i.e. it's getting less, that's negative, is proportional to, think back to your GCSE maths, is proportional to, is k times, is a multiple of the number of particles. Write down a differential equation. Done. Now that's all we can do at this stage. We can't solve the differential equation until we've done the integration that we need. Sorry, that was example 31, not 9J. Right, example 32. Newton's law of cooling states that the rate, so it's rate of loss of temperature. So let theta be my temperature. d theta dt, rate, and its loss. So it's getting less. So this is the rate of loss of temperature. Rate of loss of temperature is proportional to the excess temperature of the body over its surroundings. So the excess, what does it say? The excess temperature of the body, so the temperature of the body, take away the temperature of surroundings, where A is the temp of the surroundings. Now, as it happens in the book, they've used theta 0. Of course, it doesn't really matter what symbol you're using. Again, can't do anything in terms of solving it until we've done the integration. So that's it. Okay, exercise 33. Example 33. What are we given? Radius is r. The volume is 4/3 pi r cubed. And the surface, it says the surface, but it means the surface area is 4 pi r squared. Write down a differential equation for the rate of change of radius. So it wants dr dt. Okay, we can do that. So let's start off with dv dr. Well, dv dr is 4 pi r squared. And the reason I've done that is because it says the head of a snowman of radius r loses volume by evaporation. Loses volume by evaporation. So minus dv dr is, loses volume by, it's minus dv dt, I apologise, a rate proportional to its surface area. That's what the first sentence tells me. The rate of change, rate of loss of volume is proportional to its surface area. Okay, so dv dt then is dv dr times by dr dt, and dr dt is what it wants. Dr dt is what the question wants. dv dt, well, hang on a minute, that's minus ka. So k minus ka equals dv dr 4 pi r squared times dr dt. A I've already got. A is 4 pi r squared, so minus k times 4 pi r squared equals 4 pi r squared times dr dt. I can just divide both sides by 4 pi r squared. So dr dt is minus k. And that's it. Done. Okay, have a go at 9J, starting at question 5. Remembering, we can't solve these. We can just write these equations down. Can't solve them until we get to the integration chapter. Let me know if you need anything. See you next time.